Today we are talking about uh, inheritance in the Java object-oriented concepts. I hope you are seeing my screen. So in object-oriented concept, we talked about encapsulation, abstraction, and inheritance and polymorphism in the past, right? So what is the instance? What is the inheritance? To inherit a class, you simply incorporate a definition of one class into another class by using a extend keyword. Suppose there is a class A and class B also there. B class can extend all the functionality of the class A. So in order to do this inheritance, you need to use one keyword is called extend. If you see here, class B, the class B is extending a class A. So we developed a class A. It has int is equal to ij, and there's a method called void show ij. I'm printing the method. And we have a class B has int is equal to x. And class B has a method called show k. And system.out.println k, we are printing a k value. And here, B is a child class, called subclass. Is extending a superclass A. So build the relationship between inheritance relation between two classes. We use a keyword called extends. Whenever you use extends, B is extending A. The advantage of B is B has a complete knowledge of A and also knowledge of the B. B means B is object, can access K and also show K it can access. And also it can access int I and j, and it also can access show I and j. So when you create an object for B is equal to new B, the subclass object can access all the member variables from the superclass. So BB can invoke, the object B can invoke show K and show I and j method. Both can be invoked. So whenever you need to build this this is the fundamentally, whenever you write a code, you will be writing like this only. Most of the cases. Without inheritance, it is very tough to write a code. The advantage of writing this inheritance is that one is a code reusability will happen. And a code abstraction mechanism can be incorporated. Abstraction means you hide the complexity onto the superclasses, or you write a generic functionality on the superclasses, and you write subclasses as many as you want to make it customization. I was taking an example of a real-time example, like, we talk these animals. We know a lot of animals out there. And dog is one of the animal, and cat is one of the animal, monkey is one of the animal. If you see the relationship between dog, cat, and animal, the relationship between dog and cat is that they do have a 4 legs, and they do have the similarity, the way they gave a birth, and they do see that they have a differences, the way the dog makes sounds versus the cat makes sound. So what is the common functionality is that the number of legs is a common functionality. The way they walk is almost same functionality. So we push this functionalities, like common functionalities, into the animal class as a super class. In the dog class, you can write the specific functionality, whatever you want. That is one of the example of we can use inheritance. So in my previous example, what I was talking here, class A, int I and j, and I'm passing a constructor int ii, int jj, and I'm assigning variable I and j by the constructor. A class constructor this is. And we have a void method, show ij method. It is printing I and j values. Again, class B has a extends A, int k, int I, int L, and message equal to M. And we are sending a B constructor. This is in the B constructor, we are calling a the B constructor. We do introduce a new concept called super here. So another way of calling the constructor of the superclass is a super keyword is used to call a parent class constructor. It means that here from the class B, I can invoke the constructor of the superclass. The way I can invoke, this is the B constructor, and I'm invoking a super, no parameters. This is calling a default constructor. We no need to write every class is a default constructor. It doesn't make any sense to calling like this. I'm just showing it, but this is makes sense. Super KKLL calling a parameter constructor. It's see here, B is taking 3 parameters. B constructor is taking 3 parameters, 2 ints, 1 message, 1 string message. And A constructor is taking 2 int parameters. So when I create an object for B, B is equal to BB, new B, I'm passing 10, 20, and test string. So this is subclass object can access all the method variable from superclass. This constructor is going to here invoke this message in constructor, and it assign the k is equal to kk, l is equal to ll, m is equal to mm, assigned it. Again, I calls the same parameter is passing to the super constructor also. Only kk and ll it is passing it. And it goes to the class A, it invokes this one. And it invokes this constructor next. It assign I and j. So now I and j are holding values of 10 and 20. Values of 10 and 20. So when I create invoke B is equal to show K and BB is equal to object of B, show IJ, it invoke these methods. So this will print 10 and 20, and this will print 10. So in the inheritance, whenever a class need to extend another class, we need to use extend keyword. And a subclass need to call a superclass constructor, we use a super keyword. Super and the constructor parameters, whatever you want to call. You are technically not creating an object for A here. You are creating an object for B only, but B is internally creating an object for A also. So this is the way the inheritance will work in Java programming. In the real world scenario, which I mentioned to you, an abstraction and inheritance, they go together. So previous example, we take an animal, taken a different example, like, shapes. The different shapes like square, rectangular, triangular, and many shapes are there. You have studied this in our mathematics also. You calculate the perimeter, you calculate the circumferences of the shapes, and we can do multiple things for the shape. So you define a class called shape, you put all the common functionality of the shapes in the superclass, and you write a subclass like a triangle. Triangle extends a shape. Class rectangle extends a shape. That is another kind of an example I'm trying to explain here. I will pause for any questions here before I get into the next slide.
Sir, can you show the previous platform? Yeah. Sir, is there a need to to keep k is equal to kk and 1 is equal to 1 and m is equal to mm?
So in the class of B, integer is equal to k I have defined, integer is equal to L is defined, string is equal to M is I have defined, right?
Yes.
And the B constructor, I have mentioned that constructor is taking three parameters. One is int, one is another int, one message. I gave namings, anything I gave any name here. You can give
Yeah,
here,
we can give
give
1k, right?
here you
And
can give
again,
1k also, no problem. You can I
yeah.
gave because you people will be confused with this k and this k. That's why I gave 2k's here. You can
Okay.
give you can give your name also. You can put 3k's also. You can put 4L's also. You can put 5M's also, no issues. Or you can keep 1M. This is anything you can define, strings. So data is, so whenever you invoke this one, the control goes here, pass this parameter, 10 become KK, 20 become LL, test string become MM variable, right? And now
Yeah.
I'm assigning the data. Now I'm telling K and K, this variable is loaded with whatever is there in the KK. Means that now K become 10,
Yeah.
L become 20, M become test string. I have assigned the variable. The assignment operator I used. You see the assignment operator I used?
Yes.
Both are equal. Means whatever the value is holding KK, same value is holding in the K also. Did I answer your question, Kalyan?
Yes, sir.
So next topic which I'm going to talk about is what are the different types of inheritance which are supported by Java. So one is a single inheritance. So a class B is inherited by class A, means that A is the superclass, B is a subclass, single type of inheritance this is. And multi-level inheritance, this is superclass A, and B is a subclass for the A, and B is superclass for C, and C is the subclass for B. So base class, intermediate class, derived class, three levels are there. Multi-level. I can go as many as I want. And third hierarchy is the hierarchical inheritance. So we have a class A and B, C, D, all are extending a class. I told like an animal class. We have a dog class. We have a cat class. We can have a monkey class. Like you see that shape is the one super class. You can create a rectangular, triangle, and a square. Hierarchical we can create. And third one is the multiple inheritance. So it is extending A and B. C is a become a super subclass for both A and B. And this is all hybrid instance. B is extending A, C is extending C also extending A, but D is extending both on B and C. So this is how we can define our classes as you make a progress the way you want to do it. So most likely we have shown A and B example in the past. We can create like, A, B, C also. One example, create a class A, create a class B, class C, C can extend B, B can extend A. The third concept in the inheritance is we have talked about method overloading. We have not discussed about method overriding. Method overloading is a mechanism polymorphism on the compile time. Means we know it before the time which method I'm invoking it. Method overriding is a runtime polymorphism. And the runtime, even you don't know as a developer which method it is going to invoke by the program. That is called the runtime polymorphism. So we develop this in the method overriding. In the class hierarchy, a method has written something send message. A superclass is a message called send message. Exactly same parameter. Takes one parameter send message. Subclass also have a same method send message. Takes the same parameter string. Then create an object for the subclass. Whenever invoke B subclass, have a confusion whether I want to invoke A or invoke B because method signature is identical. When you encounter this kind of problem, generally what you need to do is that we need to use the override keyword in the subclass. Whenever you write a override keyword, it means that you are telling to the object, hey, I am overriding my method so that my superclass method are not going to be invoked. So here, give an example here. Animal is a parent class and a date one variable is there. And there is a move method and also eat method is there. Animal can move and also have a eat method. If you go to dog class, a subclass of animal, and anyhow, I am also keeping a move method here. And here also we have a move, here also. So dog object has a confusion whether I want to invoke the move of my own or I want to invoke a move of the superclass. So that is the reason whenever you encounter this kind of problem, you write a keyword called override in front of this method. Whenever you write a override keyword, it tells that dog object invoke. This is overriding the superclass method. That is called, this is overriding and this is overridden method. In this example, class parent and void show. Class child extends a parent and a method void is equal to show. But I have used the keyword of override. It means I'm telling to the child class, override the parent class, child class show. And I've written the main method. I created object for the parent directly. Object1.show I invoked. And I created an object for child object, object2.show. When I run this example, it is invoked the parent show, it invokes the child show also. Means that child knows exactly I want to invoke the child one. Here you might see and notice the difference here. Here parent and parent an object. Here parent and child, object 2. I can write a child also here, but it is possible to write, if you have a class B, is the child class is extending the parent class, you can tell parent object is equal to new child object. You can write like this also in the programming. It is allowed. But you can write here, instead of parent, you can mention child also. I'm just giving as one more kind of hint here. It doesn't mean that you need to follow like this way. You can write simplicity to avoid the confusion. You can write child object is equal to new child. So when we invoke this object, it clearly says that it has been overridden. Override method will help you to achieve the runtime polymorphism. If at all, if you have written a final word, we talked about final keyword yesterday class. If I have written a final void show, means that we talked about final means final. If you've written a final void show, I cannot override here. Final word says that this method is final. No one can override anyone in the subclasses. So what will happen in the real-time scenario is that when a project is started developing, it goes for like, a development of 5 years or 6 years. It is not like, we develop in one day. The programmers keep working for 4 years or 5 years, then the product will come out. As a journey of 4 years or 5 years, our project is keep on developing, and some of the developers are left, and some of the new employees are keep coming in the organization, and we don't even know who developed the code like 4 years back. But and also we don't know the knowledge of the previous parent classes, because parent classes has developed by someone in the year of 2020, and we reached now 2024. Those people might have left. So those people who are written in the 2020, they have already defined a parent classes. They might have already developed some of the subclasses. They know that this method cannot be changed. They will write like that a parent classes final keyword and give to the rest of the developers to develop the code. In the project, there could be architects, there are senior developers, there are junior developers. The architects and senior developers knows exactly which method to be override, with method no need to be override. They do design all these things. When they do design, they already decided exactly this method can be overridden, this method cannot be overridden, and give the more given an opportunity to the junior level developers to write the rest of the code. So that is the reason in the real scenario I'm trying to explain here. That's how the things will work. Then I have already decided as the architect, this method cannot be override. Accidentally, a developer can use this method and override it. My functionality will break. That is the reason I use the final keyword already, so that no one can change this code. Because the code, whatever the code is developing, hundreds, thousands of lines of code, 1,000 lines of code. It's very tough to understand the complete code if anyone join as a new to the organization. And it has been developing for many years, right? I'm just giving an example on these things, how the overriding will work, and what are the advantages of inside the while doing this overriding in Java classes. I will pause for any questions from anyone about the overriding.
Sir, I still didn't understand about overriding. Can you explain once?
Yeah. Whenever you are writing a class, subclass, and superclass, if a method is there in your superclass, which is called parent class, same method can be written in the subclass also. In the example of here, class parent has a method called show. Class child is extending a method called parent. Child also have a method called show. When you create an object of child, child need to understand, because child is subclass of parent, child have an access to show also, child have an access to local show also. This method. When you create an object for child, child should know which method to invoke. The child object have a confusion whether I want to invoke a parent class show or child class show. When you use the keyword called override, you are telling to the child class, I am overriding the show method of the parent class here. Means that I need to invoke this show, not the parent class show. I'm giving a preference to the child class show, wherever there is an override keyword is there.
Yes, sir. Understood now.
If you remove this override keyword, if you override this keyword and keep it void is equal to show, child have a confusion, child object have a confusion, I need to invoke this show or this show. It will not compile, first thing, my understanding, it will not compile, the code will not compile. It will have a confusion to the compiler itself. You can ask, okay, why should I write two shows? I can use show one here, I can use show two, no confusions here, right? You can say like that. But certain cases, I want to have the same names, show and show. That will help for the runtime polymorphism. So the given example here, and this example is a little bit complicated. If take an example of a shape. Shape has a area, a square has an area, a rectangular has area, and triangle has, you can estimate the area, right? In the mathematical formula. Can you find out the area of a triangle? Can you find out the area of a square? Can you find out the area of a rectangular triangle, right? You can say that, right? So you can write a method called area, calculate area in the superclass. So you define a class called shape, has a method called calculate area. Now, a square is extending the shape. There also you want to mention calculate area. The area calculation logic for the square is totally different. And you go to the triangle. And triangle area calculation is totally different. You override the area calculation in the triangle. You override the area calculation in the rectangle also. When you create an object for the subclasses, here you are manually creating objects, but some of the cases you need to create objects in a dynamic fashion. Programmatically, you need to create objects. In the runtime, you need to create objects and invoke area. Whenever I get a subclass of triangle, if shape is equal to triangle and invoke area, if shape is equal to rectangular, invoke area. If put that if else conditions, then I just simply call calculate area method that programmatically knows exactly whether I'm invoking a triangle or rectangle. I will try to build an example for this, what I'm speaking for tomorrow. We can practice this example so that you can have a better understanding how to implement this overriding in the real scenario. I will develop some example and provide this example. Is it clear to all of three?
Yes, sir.
So there is an abstract classes. Abstract means, so generally we use this abstract to define data abstraction is to hide certain complex functionality in the top level and let the bottom level subclasses can write the implementation of it. So abstract keyword, whenever you want to create an abstract, it means that abstract classes, the concept of abstract classes. Abstract classes are classes. We cannot create an object. Abstract classes are ob classes. Those classes are not complete. Whenever a class, generally we have been learning, a class will have a variables, a class will have a methods, and method have a complete implementation. So there are cases where I need to write a class and I need to write a variables, I need to write methods, but method will not be implemented completely. Means that they are dummy methods. Whenever you create the dummy methods, then you need to declare the class as abstract. Whenever a class is declared as abstract, that class, you cannot create an object for the class. If you see here, a class is animal. Just hold this abstract keyword. Class is equal to animal. And I have a method called animal sound. You see here, I have not created a fully implementation. I just open the bracket, close bracket, I put semicolon. And there is a regular method is sleep. Some sleep is implemented because I have opened the bracket. I have given a complete implementation for sleep, but animal sound, I have not created a complete implementation. Whenever I have not provided a complete implementation of any method, I need to stick in a keyword called abstract. So the compiler knows that when you compile the code, this method is abstract method. It is not completely written. Whenever a method is abstract, then class also need to be mentioned as abstract. This is called abstract classes. Abstract classes as a class will not have a complete implementation, and we cannot create an object for the abstract class. Yes, but if I cannot create an object for the class, how can I invoke this method, sleep? Only way we can create an object indirect way is by a subclass and extending the abstract class. A class pig extending animal. And here public void animal sound. Now I have mentioned animal sound. I have provided implementation here. The pig says a sound called VVV. It means that animal class don't have understanding about what to implement. I don't have anything to implement. I'm defining this, but let the subclass can take care of implementation. If you go to the another class, dog extending animal and animal sound, I have written an implementation for animal sound. You see here, dog makes a sound different says bow bow bow. I've used the same method signature. I have used the same method signature. I have used same method signature. I have not used the override keyword here. It is because in the previous example, if this abstract was not there, I have implemented this animal sound. I need to use the override keyword here because the same method I'm using it. Since it is abstract class and I am providing implementation in the subclasses, I don't need to write override keyword here. It tells that pig is extending animal. Pig have a knowledge of sleep and pig have this will ignore and pig will implement the animal sound. Hey, let me implement my own animal sound. A similar way dog. Similar way, monkey class I have created makes a sound different way. You see that in this example, the real advantage of in developing is that the common functionalities I am pushing into the abstract class, same functionality are pushing to abstract class, and any specific implementation for subclasses, I'm delegating to them. Hey, you take care of animal sound. I don't know. I know about animals, how they sleep. Let me write the code for sleep. You don't need to write. I know pig how it sleeps. I know dog how it sleeps. So that is reusability. I've written sleep method at one time on the top level, so that the pig is no need to worry about how to write sleep. Dog is no need to worry about how to sleep, because for a dog also we have taken care the how to sleep function will work. Do not compare when I say dog and pig, literally animals, how they're sleeping it. Just take an example of here, reusability. So you only need to take care of animal sound. So that is the reason pig is worrying about developing animal sound. Dog is worrying about animal sound. Code development will be much faster and pushing the common function to the top. After deploying this code into the production environment after 2 years, something happened, some issue occurred. Sleep function is not working. Simply developer goes and make changes here. Instead of suppose, since the sleep is reusable, if you put a fix here, enhance the code, all the pig and dog, everything will be adjusted. Otherwise, if this method is not here, if you write a method sleep here, if you write a method sleep here, assuming that we don't have a inheritance, we have a simple pig class, animal sound, and we have a sleep class, and a simple dog class, animal sound, sleep. Like the way hundreds are there, animals. 100 methods have a sleep method. Some changes happen. I need to change the sleep pattern. I need to go and update a code for 100 times. So advantage of here is, if you write like this way, if something need to be changed, sleep, I go and change the one line of code, couple of lines of code in this. It will be applicable to all the classes. The reusability will be increased while writing the code like this. It's coming here at the bottom. I created an object for pig, created an object for the dog. I invoke the animal sound. For dog also, I invoke the animal sound. So abstract class will help you to provide abstraction. And subclasses will take care of the complete implementation. So total in the in inheritance, you have extend keyword and we have a super keyword we talked about. We have talked about override keyword and we talked about abstract keyword. Extend keyword helps to extend a class A to class B, and super keyword helps to call the constructor of the super method, super constructor, parent class constructor. And override keyword help you to override the method in the subclass. Abstract keyword help you, it'll tell the abstract keyword, will help you to mention the class is an abstract when we are not providing a complete implementation for the class. Abstract classes are definitely being used in the day-to-day programming. I will stop here for any questions from anyone.